Hello students, in this video we'll see the third unit, that is types of input devices and types of output devices. So first we'll look into the type of input devices that we have for our systems. The most common one or the input devices that you're already aware of are keyboard and pointing devices such as a mouse. You are also familiar with other input devices like digital camera, webcam, scanners, and maybe some of the input devices or input methodologies you may not be knowing are OCR, OMR, also you might have heard, MICR, also you might have heard somewhere, and the barcode reader. So you have heard of these things, but are you really aware how these things work? No, right? So we'll see how exactly these things work, and it's not into too depth of these working, but you should know what actually generally happens in these devices and how the information is read, so that you understand how complicated actually the system is, and you get to know what is the technology behind these things, or what is the ideology that is being used behind these devices. Okay, so let us see all these things one by one. So you're already aware computer has four components like CPU, input devices, output devices, and memory, and we have studied CPU and memory to a little depth to some extent, right? So we'll see in this how the input devices provide data to the CPU for processing, and after processing the input data, how it is converted into meaningful information and sent to the output devices, and how this input devices, which is an electromechanical device, uses or allows the user to feed information to the computer for analysis, storage, and how it gives the commands to the system. So after processing the data from the input devices, computer provides a result with the help of output devices. We all are aware of it. And an output device converts a machine readable information into human readable form. Okay, so we'll see how this happens. So if you see this picture, you can see this is the input device. So whatever the information is given through the input devices, that is the keyboard, so the data is coded and in the computer understandable form. So the CPU understand what it is, and it is a process to the process data is sent to the output device. So that could be monitor or printer, whatever it is, but usually the first thing it's displayed in the monitor, right? So how the output is given via the output device, we'll see in this unit. So what is the importance of this input and output device? So there are mainly three steps, that is data input via input devices, process the data, and data output via an output devices. They play a major role in processing any data to the computer system, because output is always based on the input provided, and we know the famous kind of saying in our system, that is garbage in, garbage out. If you put the garbage into the system, you only get the garbage, it won't be turned into a useful material. So that is why you have to be very careful while giving the data or when you input the data. So input device should manipulate this raw data and send for the further processing. So then what are the types of input devices we have? That is, usually it's manually or directly. So manual entry in the sense the user enters data through the keyboard or mouse, you know it. What do you mean by directly then? It is transferring information automatically from a source document to the computer. That is, either it could be a saved information in the system, or it could be a saved information on a pen drive or so. So whatever it is asking to do, it is done without just with the commands that are in the document. And some common input devices are keyboard, mouse, scanners, speech recognition, etc. Speech recognition also, it's a kind of blooming now, because we have that in our Google Talk. Usually you give the command through your speech, right? Or the what you speak is converted into command. Okay, that is speech recognition, and we'll see a little detail in the further slides. So first thing is the keyboard that we have. So using keyboard we give the text commands, and the keys are arranged in the form of a regular typewriter, right? See, keyboard is the like kind of a modified version, or a better version of a typewriter, it. Along with the typewriter keys, there are few additional keys that helps in the working, and data is entered by pressing these keys, and this keyboard has never changed since it has been introduced. Why? Because people are adjusted to this key arrangement, that is we call mainly the QWERTY keyboard, right? And all the phones or even the mobiles or laptops and computer keyboard, whatever it is, we use the same keyboard layout. So variations are just with the few additional keys available. Like for example, for the systems or the laptops, you have additional number keys, additional function keys, but either that is not present in your virtual keyboards that you have in your mobile phones, right? So that varies in that only, so few matters. So this is our keyboard, like looks like it. And see, let us just get familiar with some of the keys that are available on the keyboard. So this is called the tab key. Tab key in the sense, actually if you want to start a paragraph, you need some space at the starting. For that we press a tab. Then we have this caps lock key, that is for typing something in capital. Like you have continuously, if you have typed something in capital, use the caps lock key. And next is the shift key, that is while just one letter, if you have to type in capital, you can use the shift and that key. Also to type the numbers, or the symbols present in this number key here, that for that also we are using the shift. The control is to perform some of the control to give some control commands to the system, like open the file or save the file. Like for example, control S, if you press, the file gets saved. And it's like maybe to some other commands that you're giving through the keyboard, you use the control key. And the next is the alt key. It also, again, it is used in the combination with the control or some of the keys. And this is the space bar, that is for the space, white space you are using it. And these are again the similar keys repeated here, because if at all the keyboard one key is not working, you don't have to actually you cannot work if you don't have even some keys that are frequently used. That is why you have this key, so that in case these keys don't work, and you can work in this one thing. One more thing is, it is easier, like if you are typing in your right hand, these keys are necessary, and if you're typing with the left hand, this is necessary. And the keyboard layout is planned in such a way that you use both the hands to type. And students, while typing even in your labs, please use both the hands. It's not for single hand use. So for that, these keys are used. And this is the enter key to enter into a new line. And this is the backspace, that is to delete the presently typed word, that is the cursor goes backwards. These are the function keys, again used for some of the functions. Like instead of using some of the commands or the combination of commands, you can just use, for example, if you press F5 here, the screen gets refreshed by itself. Okay, so then there are some keys that directly opens the help form, all those things. So function keys are used for the special functions for the system. Escape is either you escape the current working window, and it goes to the previous window or whatever the background is there. See, these are the arrow keys. Arrow keys is just to move the keys like cursor up and down. And this is the delete key, that it deletes actually the next or the present where the cursor is present letter where the cursor is present, that is a deleted. Then this is a print screen. Print screen is like a screenshot in your phone. Okay, for that it's used. The screenshot is, it directly is saved as a photo, but print screen is a saved as an saved in the clipboard. That is, you do this copy to clip, do it in a phone, right? Like same way. And if you want to access this, you have to paste it somewhere on the document. Okay, it's like a cut option. The cut of your screen, whatever is present in the screen is just cut. And if you want to use that, whatever the portion you have just on the screen, you need to paste it on some document, then you can use it. Okay, so that is why print screen is used. Then num lock, that is, if you press this num lock, the keyboard of this will not be working. And if you again press it, so you can use this keypad, that is numeric keypad, you can use. So this is how it looks like, and you're familiar with the keys present in the alphabets, right? The arrangement. It's called the QWERTY keyboard because a Q, W, E, R, T, Y are the first 6 letters in your keyboard. That is why it's called a QWERTY keyboard. So this is how it looks like. You've seen a keyboard anyhow. So let us see what it does and all that. So laptop keyboards are slightly different arranged from the desktop keyboards. Almost similar but a little different. So they add some special key buttons, and to the standard keyboard, sometimes it also has some extra buttons for sound, and even the dark, the brightness of the screen, for all those things. And also some for the mics, for the wireless accessing of your internet, all those things. There are sometimes a special button, but nowadays what they do, they just put it in the keyboard itself with the main keys. Okay, next is it is the easiest input device, so you don't have to have any special skills to operate this. And maintenance and operational cost that for these keyboards is very low, and it's a slow process putting all data from the keyboard, hard for people suffering from muscular disorders. That is, if you cannot type the keys faster, then it will be a slow, and people might find it difficult. Like the keys are present very near to one another, so while typing also you have to be careful that you don't press one key for one alphabet. So those are things, it's necessary to be necessary to do from the user part. So if we know how to press a key, we know how a keyboard actually how it gets loud, how we can get the output on the screen. But do you know what are the things happen when you actually press a keyboard? For example, you're pressing D on your keyboard. How do you think it's not simply D? When you press, you just get it on the screen, of course. But how actually the D is pressed? So it's not simply you are typing here and it's like a seal comes on your keyboard. No. Why? Because that whatever you are typing, or whatever the computer understands, is just the zeros and ones. That is a binary, right? It cannot understand your English, that is a that you have pressed a key D, and that is why it's writing on the screen as D, or printing it on the screen as D. No, it just does not understand what a D is. But what does it understand is, if you type the key as D, then which part of the screen it has to highlight, or for example, if a screen is in a white background, then what are the parts it has to darken. Only that it knows, and it does not actually even know what shape it has to write and all. We actually give the or either it is predetermined in the typing screen, or else we change the font, right? We write a D in different various fonts. So how does the computer understand this and determine that it is a D? Okay, we'll see that. So it is a series of switches connected to a small keyboard processor that monitors the state of each switch and initiates specific action to change in state. That is, once you press the key from the keyboard, that space whatever you have pressed on the keyboard, the microprocessor attached to this keyboard gets activated in the space like what alphabet it was pressed or what key has been pressed on the keyboard. Okay, so what does actually do, it causes the change in the current flowing through the circuit because of that press in the keyboard. It's simply to understand, you can imagine that you have studied in your physics classes in your high school about the switches, like how you press a switch or how you on the switch, the bulb glows, right? Or at least in your homes you or you know how a bulb or a fan works. Like when you switch on, the fan works. When you switch on the bulb switch, it ons. Okay, same thing, as you press the, it makes a change in the current flow through the circuit. So the keyboard microprocessor detects this change in the current flow, and by doing this it can tell which key is pressed and when it is released. See, this is how it works. You press this key, okay, so it goes. See, this is the microprocessor of the keyboard. Here the current changes. So when it changes, it can determine that what key was changed, like in what space this key is present and how the current has been changed through the flow of through the press of this button. So when it is determined by the microprocessor, it understands what alphabet it was, and that alphabet is sent to the it's checked for how long it is pressed. It depends on what key you are pressing, but usually once if you press only once, it will take the information. So if one key is pressed, so one that the time for what it was pressed is recorded, then it understands, okay, this was the key pressed. Then it is passed through the operating system. System determines what what it needs to do. Like for example, if you are having this screen like WordPad or the Microsoft Word and you are pressed D, it means that it has to type. D has to be typed. Okay, so if you press Shift and D, then it has to type that the D is capital. Okay, so that all those commands, like that conversion is got or understood or made understand by the operating system. Okay, then the operating system sends the information for the output device, that is the monitor, and there it is typed. Here it was typed as A, that is why A is typed on the screen. So simply when you press the key, the processor generates the associative code called as a scan code. That is, it scans the what key was pressed in the keyboard, okay, and of the key, and sends it to the operating system. The copy of this code is stored in the keyboard's memory. Okay, there is a small like buffer for a little time, like what it was pressed to remember that. For example, you do this undo and redo, right? So it has to know like what was the last key pressed or what is the last few keys that was pressed. So there is a memory associated with this keyboard. So when the operating system reads this scan code, it informs the keyboard, and scan code is stored in the keyboard's memory. Okay, so this is how a keyboard is typed. Now the pointing device, that is mouse, that usually we use is a mouse. So why is pointing devices? You'd see in a little back when we started using the computers, there was no mouse in it, there was only keyboard. Then why do you think pointing devices or a mouse came into existence? It's simply because it becomes easier. Like for example, otherwise this user has to remember every command he has to type for the opening of the document, closing of the document, or whatever he needs to do. But now what we can do, we can just click on the icons that are present, that is, we call it as a graphical user interface, the icons present in the system, and we just need to click it, because it is said that human memory remembers the pictures very well rather than the commands and all that. So it's a easier way to work on the system. That is why we have this pointing devices as well as the graphical user interfaces. And instead of typing the command, you can just click on those buttons, or there are some commands already written and you just need to click on those commands written on the drop down menus maybe, or just the name of the file maybe. You just have to click and it gets opened. Okay, so it is used to communicate with the computer by pointing on the locations on the monitor screen. So since they don't need the characters, they can we can just move the cursor and perform the operations. And for a clicking of that mouse button, that is pressing of that mouse button, we call it as clicking. Okay, that is the left button usually is called just the clicking, and only when we want to press the right button, we call it as a right click. Otherwise it's just called just the click. We don't call it as a left click, it's just a click. Okay, and the click and the right click. And dragging is you just click, don't leave the mouse button, and you just move wherever you want. You have done all these things, but I'm telling you what actually it means. Okay, so that is dragging. So what are the pointing devices we have other than mouse? That is, one is a mouse, of course you know. Next is a trackball, joystick, light pen, and touchscreen. We'll see these things one by one. So you have used a mouse, but how do you think it works? And mouse, since when you are moving, that is when some mechanical work is being done, the mouse pointer moves on the screen. So it means that there are some mechanical work or the mechanical techniques used inside the mouse that converts mechanical, that moving part, or the moving of this mouse device is converted into electrical signals, and that electrical signals is pointed in the form of a pointer. So when you click is also again a physical or a mechanical work that is actually pointed, or that is actually converted into electric signals, and we see the work being done on the screen, or you can say it as a virtual work that is being done. So mouse is a small handheld pointing device with the rubber ball embedded at its lower side and buttons on the top. So with this mouse I'm talking about the mechanical mouse that was used before. Now we are using the optical mouse. You have seen all the mouse has a light. Actually it's an infrared that we see under the mouse, right? When you lift the mouse, when you just pull, you might have seen it, there is a red light that is glowing when the mouse is on. So before that came that optical mouse came into existence, the mechanical mouse was used. How this mechanical mouse worked? There was a rubber ball inside the mouse. It's like you're moving the ball, and when you move the ball, because of its movement, or the the distance it has covered, or the that spin it has happened, that is measured by the some of the technology used inside the mouse, and that gives the exactly how far is the mouse pointer should move on the screen. Okay, that is the overall technology inside the mouse. So what is it? We now have that scroll that is in between the right and left button. We have a moving scroll, right? There is a kind of button kind of thing that actually moves. We scroll for the screen up and down, for the screen to move up and down. But before this 2-button mouse came into existence, there was a 3-button mouse. So these two are also used for the same purpose. So it's like instead of scroll, there was a third button, okay, which can be which was used to input information, of course, this mouse. And they're classified as optical and mechanical based on the technology they are using in them. And mechanical mouse uses a rubber ball at the bottom surface, which rotates as the mouse is moved along the flat side. You just imagine that there is a ball, and upon that you are actually mounting something, so that you understand how far the ball has moved. Okay, so this is how a mouse looks like. See, this is but these are 2 buttons. This is the scroll that we are using to move. So this is the optical mouse that is in trend nowadays. So it is a commonly used cheapest pointing device. It, as I told you, it has a light beam, and it rotate ball. It detects the mouse movement. The rotating ball detects the mouse movement. As the user moves the mouse, the cursors on screen also moves. You know that. So it's a costlier than mechanical mouse and does not need a mouse pad and always accurate. We are talking here about the optical mouse. And the mouse allows us to create graphic elements on the screen such as lines, curves, and freehand shapes. We have seen, or we are going to see this in our practicals. And we are using, you might have used the word also, in that also we are using this arrow marks, lines, and such things. For this mouse, you don't have this, installing cost or anything additional cost. It comes along with the keyboard. Okay, as monitor and keyboard, you get the mouse also. And to use this, you need a flat surface. You cannot use on a very smooth or curved surface. You cannot use it. You need a flat. And in laptops, instead of this, you have a what we call as a touchpad, or also we have a trackball. So how does this work? As I told you, it has a rubber ball, moves when the rubber ball moves over the flat surface, the ball rolls. The distance and direction and speed of the mouse ball's motion is tracked. Information measured is used to move the cursor inside the screen in the computer. So there are actually three rollers in this mechanical mouse. One of them, which is mounted at 45 degree to the other balls, is spring loaded. See, this is the mouse ball actually. See, this is actually, there is a outer case, and usually this part is covered, and this is kept on a desk upside down. Okay, so that when you move, this ball is actually touching the table. Okay, and for this we have this ruler. See, this one and this one. So when one ruler moves, it determines how fast it is moving. See, we'll see. See, one is the smallest of the three balls, okay? And other two rollers are usually larger and different in color. See, this is the smaller one. These two are the bigger ones. Then these rollers are mounted at 90-degree angle to one another. One roller measures how fast the ball is turning horizontally, and one is for the vertical direction. That is, one sees how far it is moving in this way, and this is seeing how far it is moving this way. Okay, you need, like, ball, it just moves on, right? In any direction you can move. That is why it's that curved surface, or the sphere, it has a special property. It's not like your cubes or rectangle, the cuboids. Okay, so that is why it can move in any direction. So this is for the vertical direction and this is for the horizontal direction. These rollers are kept to measure how far it is moved. And when the ball rolls, it turns these two rolls, and these are connected to axles, which are connected to the sensors that measure how fast the axles are turning. That is, see, this is the roller, this is the axle, and this says how fast the ball is moving. This says how fast the ball is moving, and this is connected to, this is the board, and here the sensors are there which measures how far actually this ball has moved, and then it is converted into what? Electrical signal that is passed through this wire to the your system. Okay, and there it says from to whom the information should be sent. For example, first is sent to the operating system, and on the operating system it is given to the monitor for the display. So there is a small processor present in the mouse which consists of more than one chip, which uses the information for how fast the mouse is moving and in what direction. So the information passed to the computer via mouse card, where the operating system then moves the cursor accordingly. So whatever seen now, it was a mechanical mouse. Now I told you, nowadays what we are using, it's not a mechanical, it's a optical mouse. Then what's the difference? Axle in the optical mouse is connected to a little photo interrupter wheel with the number of tiny holes in it. So when it has a tiny holes, what happens is it's like a light is passing, okay, and there is a disc in front of that light, and this disc has holes, okay. So in one direction, like in if at all it is moving, some like the light is being passed and your disc rotates, okay. So what happens, where there is a hole, the light passes through the hole, and where there is no hole, what happens, the light is obstructed, right? That is what a photo interrupter wheel works like or looks like, okay, with the tiny number of tiny holes in it. In front of this wheel, there is a light source. On the other side of the wheel, there is a meter. And when the wheel turns, light flashes occur. That is, once the light flows to the hole and something it comes obstructs the light, then the light sensor cannot know the light. Okay. In this way, with this, passing of light and abstracting, passing of light and abstracting, the light sensor can measure how fast the wheel is turning. Okay, it is, if it is turning fast means the mouse is moving faster and it moves accordingly, right? You can move the mouse pointer slowly or even faster, right? You might have seen while playing the games also, it moves very fast. But if you're typing or if you're just clicking on few things, you can move it slowly. So these values are sent to the computer, and accordingly the speed of the mouse is determined. So computer moves the cursor as per the values received from the mouse. I told you, as this rotates faster, the mouse moves faster. When it rotates slow, it moves slow. So this happens 100 of times per second. That is, it's very, very fast. So when we see this cursor moving, it is actually very smooth. So next one is the trackball. Now if you think what this trackball may be, we have seen a mechanical mouse which has a ball in it, right? Similarly, instead, I told you that is actually up, the figure what you have seen, it's upside down, right? That mouse actually touches the table. Now what if I just use the mouse that way itself? That is, you are moving the mouse with your fingers. Mouse in the sense that ball, okay, that rubber ball with your fingers, and same mechanism happens. It's nothing but the trackball. That is, you can see the trackball above. It's not like mounted below. You are moving just the ball with your hands, with the help of your fingers. And when you move this by fingers, the mouse also moves accordingly. So again, the size varies from small to small as marble to a big one, as a cue ball in the sense that we are using in billiards. Okay, in billiards we use a little bigger size balls, right? To up to that size you can have this, and it comes in various shapes like square, button. Okay, so this is how it looks like. See, this is a trackball. So I told you, it's like up upside down mouse. Okay, here we have this trackball. See, this is the trackball. Mainly it's used in control mouse movements, actions on the screen with the help of a fingers, and not entire mouse. Means you have to move your arm, right? That is, you have to move your whole hand to move the mouse. But for this, in just fingers you can use, and the movement is very precise. Okay, exactly to the way you want to go, the cursor you want to move, it can be done by using this thing. So that is why it is used by graphical designers and gamers. And it requires less space, because mouse, if you are moving, you have to move the whole mouse, and to move that whole mouse you need a little space on the table top or wherever you are using it. Okay, but this does not need, because the ball moves only on that case, or whatever the track ball has, its a case inside that only this moves. And in the form of a button, it can be reprogrammed according to the function, and it does not come with a computer. So if you want it, you should buy it separately. So a little additional cost will be there. One more thing you're all familiar while playing the video games, maybe, or on the computer, or some of the games, that is a joystick. So you have seen, it's like mm, that moves in all direction, okay, and controls the movement of the cursor. So the basic design consists of a stick that is attached to a plastic base with the flexible rubber sheath. You can compare it with the gear of a vehicle. You have seen that, right? Same thing. It moves in that way, and it also has that flexible rubber sheath and a plastic base. There it is a different thing, but to look at it, it looks a similar way. And the electronic circuitry measures the movement of the sticks from a central position, that is where it is present at the central, then it is moved from a right or a left, okay. And it also has a buttons, it's not just a stick, and above it there are buttons also, so you can program it accordingly. And so its types of control are digital, glide, and direct. Glide in the sense to move smoothly, or digital in the sense the digital movements, or direct to direct in which way the cursor should move. See, this is how it looks like. See, this is the button. These are the buttons present on the joystick. Okay, so this is the plastic base. This is the rubber sheath around the joystick. So it's a digital control allows movements in a limited number of direction, that is top, down, left, and right. Okay, and the glide and direct, what we have, the type of joystick, they allow the 360-degree movements, and it is used to control the velocity of the screen cursor movement, rather than the absolute position. That is, it is used for the speed movement. It does not bother if you are moved exactly to the point where you want it to move, but it's just for the speed movement. That is why it is used in the games. In the games, you have seen, like, for the fast running of whatever the character you are playing, or just you need to move to that place. But see, you need not move exactly to the point where you want to go. Like, if you go near to that position itself, or near to the space where you need to go, that gets selected, right? That whatever the function it was to be done, that happens. And it is also used in flight simulators, like flight simulators in the sense how you actually fly. There is a virtual uh, you know mm, arrangement for that. You don't actually have to fly, just the movement can be learned through virtually, like just like you are having this learning of vehicle digitally, right? Or virtually, we call that as virtual classes, or training, or simulators, whatever you can say. So in that also it's used, and in the CAD cam systems and controlling industrial robots also it is used. So light pen we'll see in the next video.